Hello and welcome to Astronomy Daily. I'm Anna, your host, and I'm thrilled to have you join us for another journey through the latest and most captivating stories from the cosmos. Today, we're delving into some truly fascinating developments that span from the challenges faced by astronauts in space to humanity's ambitious future on the moon and beyond. We'll start by exploring an unexpected side effect of space travel, how it can permanently change an astronaut's eyesight. Then, we're heading to the moon to look at South Korea's bold plans for a lunar base by 2045, showcasing the growing global race to return to our celestial neighbor. Next up, we'll dive into the incredible potential of NASA's upcoming Nancy Grace Roman telescope, which is poised to uncover tens of thousands of cosmic explosions and shed light on mysteries like dark energy. Finally, we'll take a trip back in time to the Apollo 11 mission, revealing the little-known stories of where the Eagle could have landed if circumstances had been different. Stick around. It's going to be an exciting episode. Imagine this. You've spent months aboard the International Space Station, witnessing Earth from an unparalleled vantage point, performing groundbreaking science, and pushing the boundaries of human exploration. You return home, a hero, but with an unexpected side effect. Your eyesight has changed. This isn't a rare occurrence. It affects about 70% of astronauts on long-duration missions, and it's got NASA scientists intensely focused on understanding why weightlessness impacts our vision so profoundly. One astronaut, Dr. Sarah Johnson, reported that text perfectly clear before her 6-month ISS stay became blurry. She's far from alone. Astronauts frequently report difficulty reading, blurred distance vision, and other visual changes that can persist for years after returning to Earth. This condition has been given a name: Spaceflight-Associated Neuro-Ocular Syndrome, or SANS. It has rapidly become one of the most pressing health concerns for extended space missions. Unlike other temporary issues like motion sickness or muscle weakness, which quickly resolve on Earth, SANS-related vision changes can unfortunately be permanent. The primary culprit appears to be microgravity itself. Here on Earth, gravity consistently pulls fluids downwards through our bodies. In the microgravity environment of space, these fluids redistribute. This leads to facial puffiness and, more critically, increased pressure inside the skull. This elevated intracranial pressure can flatten the back of the eyeball and cause swelling of the optic nerve, directly impacting vision. These findings carry significant implications for future missions to Mars, which could realistically last 2 to 3 years. As Dr. Michael Roberts, NASA's vision research lead, put it, we need to understand whether these changes stabilize or continue worsening over time. An astronaut with severely compromised vision could jeopardize an entire Mars mission. To combat SANS, Dr. Roberts and his team at NASA are actively developing various countermeasures. These include specialized contact lenses, medications designed to reduce fluid pressure, and specific exercise protocols that might help maintain normal circulation. They are also testing an innovative device called the Visual Impairment Intracranial Pressure, or VIIP chamber, which could simulate Earth-like pressure conditions for the eyes while in space. While SANS presents a serious challenge for space exploration, this research offers a broader benefit for everyone on Earth. Scientists are gaining invaluable new insights into how pressure affects vision, which could potentially lead to improved treatments for conditions like glaucoma and intracranial hypertension here on our home planet. Understanding how our bodies adapt to and are affected by space remains crucial as we continue to test the limits of human endurance and explore further into the cosmos. The research into solutions will continue at NASA and on board the ISS, with the hope that when humanity finally embarks on a trip to Mars, our vision will be clear enough to fully appreciate what we have accomplished. Shifting our gaze from astronaut health to ambitious national goals, let's talk about South Korea's burgeoning space ambitions. The nation is making headlines with its bold plan to establish a moon base by 2045. This significant goal was revealed in a long-term exploration roadmap laid out by the Korea Aerospace Administration, or KASA, which was established just last year. KASA's roadmap outlines 5 core missions, encompassing everything from low Earth orbit and microgravity exploration to lunar exploration, and even solar and space science missions. A key focus for KASA is developing homegrown lunar landing and roving technology, alongside the crucial ability to extract and utilize moon resources like water ice. Some of this preparatory work is already well underway. For instance, the Korea Institute of Geoscience and Mineral Resources has been testing prototype lunar rovers in an abandoned coal mine, practicing techniques that could be vital for future space mining operations. South Korea isn't new to lunar endeavors. In August 2022, the nation successfully launched its first moon probe, known as the Korea Pathfinder Lunar Orbiter, or DANURI, atop a SpaceX Falcon 9 rocket. DANURI reached lunar orbit 4 months later and is still actively studying the moon with its array of instruments, proving South Korea's growing capabilities in space. While South Korea had already aimed to place a robotic lander on the moon by 2032, this newly revealed roadmap significantly ups the ante. The plan now includes developing a more capable moon lander by 2040, all with the ultimate goal of building a robust lunar economic base by 2045. It's important to note that South Korea isn't alone in this race to the moon. The United States, through NASA's Artemis program, also plans to build lunar outposts in the coming decade. China is pursuing similar goals, often in partnership with Russia and other nations, and India has set its sights on a moon base by 2047. The moon isn't CASA's only distant destination either. The agency also has its sights set on South Korea's first ever Mars landing, also by 2045. Now let's shift our focus to a truly exciting development on the horizon. NASA's next big space telescope project, the Nancy Grace Roman Telescope. Astronomers are absolutely buzzing with anticipation for its launch, currently set for no later than May 2027. And for good reason. Recent research suggests that Roman, during its high-latitude time domain survey observation program, could discover an astounding 100,000 powerful cosmic explosions. We're talking about a dazzling array of violent events, including supernovas marking the dramatic deaths of massive stars, kilonovas, which occur when two of the universe's most extreme dead stars, or neutron stars, violently collide and even burps from actively feeding supermassive black holes. Roman might even detect the explosive destruction of the very first generation of stars in our universe. These cosmic fireworks are more than just spectacular sights. They're crucial clues that could help scientists finally crack the mystery of dark energy. That's the placeholder name for the strange, unseen force that's causing the expansion of the universe to accelerate. According to Benjamin Rose, an assistant professor at Baylor University and the research leader, this survey will be a gold mine, whether you're exploring dark energy, dying stars, galactic powerhouses, or even entirely new phenomena we've never encountered before. Roman will achieve these explosive results by systematically scanning the same vast region of space every 5 days for a period of 2 years. These observations will then be meticulously stitched together to create incredible cosmic movies, revealing a wealth of these dynamic events. Many of the explosions Roman detects will be Type 1a supernovas. These particular cosmic blasts happen when a dead star, known as a white dwarf, greedily siphons material from a companion star until it becomes unstable and erupts. Type 1a supernovas are incredibly valuable to astronomers because their light output and peak brightness are so consistent from one event to the next. This makes them what astronomers affectionately call standard candles, allowing them to accurately measure cosmic distances. The new research, which simulated Roman's entire high-latitude time domain survey, indicates the telescope could uncover up to 27,000 new Type 1a supernovas. That's about 10 times the combined total from all previous surveys. By observing these standard candles across immense and varying distances, astronomers are essentially looking back in time, enabling them to pinpoint how fast the universe was expanding at different points in cosmic history. This unprecedented wealth of Type 1a supernovas should offer significant hints about the secrets of dark energy. It could even help confirm recent findings from the Dark Energy Spectroscopic Instrument, or DESI, which suggests that this mysterious force might actually be weakening over time. As Rose explained, filling these data gaps could also fill in gaps in our understanding of dark energy. Evidence is mounting that dark energy has changed over time, and Roman will help us understand that change by exploring cosmic history in ways other telescopes can't. Beyond dark energy, Roman will also shed light on the life cycles of stars. The team estimates that as many as 60,000 of the 100,000 cosmic explosions detected could be core collapse supernovas. These occur when massive stars, at least 8 times heavier than our sun, exhaust their nuclear fuel and can no longer support themselves against gravitational collapse. As their cores rapidly implode, their outer layers are violently blasted away. This process disperses elements forged within these stars throughout the cosmos, providing the building blocks for the next generations of stars, their planets, and perhaps even life itself. While not directly linked to dark energy, these events are crucial for understanding stellar evolution and the chemical enrichment of the universe. Rebecca Hounsell, a member of the research team from NASA's Goddard Space Flight Center, highlighted how Roman's data will allow scientists to distinguish between different types of cosmic flashes. She noted that while searching for Type 1a supernovas, Roman will collect a lot of cosmic bycatch, other phenomena that may not be useful for some scientists, but will be invaluable to others. Among these rarer cosmic gems, Roman could detect tidal disruption events, or TDEs, where black holes ruthlessly devour stars that wander too close. As the star is torn apart by immense tidal forces, much of its material is spewed out at near light speed, creating powerful emissions that Roman will hunt for. The team predicts around 40 such star-destroying events could be found. Even more elusive are kilonovas, those explosive bursts of light that happen when two neutron stars smash together and merge. The team estimates Roman could uncover around 5 new kilonovas. While that number seems small, it's a huge deal, as only one kilonova has been definitively confirmed to date. These observations are vital for understanding the origins of precious metals like gold and silver. While most elements are forged in the hearts of stars, the extreme conditions of neutron-star collisions are thought to be the only cosmic furnaces powerful enough to create elements heavier than iron, like gold and plutonium. Studying the light from these kilonovas helps us understand this fundamental process. Kilonova studies could also reveal what types of celestial bodies are formed when neutron stars merge, perhaps an even larger neutron star, an immediate black hole, or something entirely new. Perhaps the most thrilling potential discovery Roman could make is the observation of the strange, explosive deaths of the universe's very first stars. Current theories suggest these early, massive stars may have died differently than modern stars, undergoing what's called a pair instability supernova. In these colossal blasts, gamma rays within the star could have generated matter-antimatter pairs, leading to a self-detonation so powerful it theorized to leave nothing behind but the elemental fingerprint of its lifetime. While astronomers have dozens of candidates for these events, none have been confirmed. The simulation suggests Roman could turn up as many as 10 confirmed pair instability supernovas. As Rose put it, they're incredibly far away and very rare, so you need a telescope that can survey a lot of the sky at a deep exposure level in near-infrared light, and that's Roman. The team plans further simulations to explore Roman's full capabilities, which might even include detecting phenomena not yet theorized. As Rebecca Hounsell aptly summarized, Roman's going to find a whole bunch of weird and wonderful things out in space, including some we haven't even thought of yet. We're definitely expecting the unexpected. This groundbreaking research, by the way, was published on July 15th in the Astrophysical Journal. From the cutting edge of cosmic discovery, let's take a quick look back at one of the most iconic moments in space history, the Apollo 11 moon landing. On July 20, 1969, Neil Armstrong's famous words, "Houston, tranquility base here, the Eagle has landed," marked humanity's first steps on another world. But what if those words had been uttered from a different location on the lunar surface? It's a fascinating thought, isn't it? The truth is, that historic phrase could very easily have come from a completely different part of the moon. In February 1968, NASA's Apollo Site Selection Board had narrowed down a list of 30 potential landing sites for Apollo 11 to just 5. Among these were 2 sites on the opposite side of the lunar disk from Tranquility Base, specifically in Oceanus Procellarum, also known as the Ocean of Storms. Each of these prospective landing zones, which were roughly 3 by 5 miles in size, underwent intensive orbital imaging and a rigorous selection process. The criteria were incredibly strict. Each site needed to be within 5 degrees of the lunar equator to minimize fuel consumption. There could be no large hills or deep craters along the lander's approach path, as these could confuse its landing radar. Furthermore, each site had to have a slope of less than 2 degrees, with relatively few craters, and excellent lighting conditions during the chosen landing windows. Ultimately, Site 2 in the Sea of Tranquility was selected as the prime landing location. However, two of the other shortlisted zones were designated as contingency landing sites, ready to be targeted if the launch of Apollo 11's mighty Saturn V rocket had been delayed. Imagine if the mission's launch had slipped by just 2 days, from July 16th to July 18th, 1969. In that scenario, humanity's first steps on the moon would have taken place in the Sinus Medii region, right in the center of the Earth-facing lunar surface. And if the launch had been pushed back even further, to July 21st, 1969, then the footprints would have been left in the regolith of Oceanus Procellarum. While Tranquility Base has certainly become a legendary name, Procellarum Base just doesn't quite have the same ring to it, does it? It's a compelling reminder of the meticulous planning and the precise conditions that led to one of history's most defining moments. And that brings us to the end of another fascinating journey through the cosmos on Astronomy Daily. I hope you've enjoyed exploring these stories as much as I have enjoyed sharing them with you. Thank you for tuning in and being a part of our cosmic conversation. This has been Anna, your host, and I invite you to keep exploring the wonders of the universe with us. You can become a completionist and listen to all our back episodes and even get a shout out on the show by visiting our website at astronomydaily.io. That's astronomydaily.io. And don't forget to subscribe to Astronomy Daily on Apple Podcasts, Spotify, and YouTube, or wherever you get your podcasts so you never miss an update. Until tomorrow, when I'll be back to do it all again, keep looking up.